So hello again and welcome to part, what part is this? Hold on, let me look. Oh my goodness! Look at this! 56 new subscribers in the last 28 days. Most of which I'm sure is within the last 2 weeks. Thank you guys so much for all of the likes, all the love, all the great comments. You're really inspiring me to make more of these videos. All right. I'm not going to let my head get too big now. Welcome to part 4 of the Classicladder Basic Introduction for LinuxCNC. I want to go over a couple of things regarding rising edge, falling edge inputs, and set and reset outputs. And then if we have some time in this video, we'll get into a couple of other things. I do have to touch base on timers, counters, variable sets, and then I have to figure out jump and call coils so I can show you guys how to do it. So getting into it, what I have down at the bottom of my current ladder project here is I have a latching circuit using a set and a reset memory coil that ties to a momentary switch on the outside world. So let's think of the momentary switch. Eventually what it's going to become is it's going to become a momentary button on an operator panel that when I press that momentary switch, it's going to latch an internal coil, and it's going to set the machine into not only feed hold but also single step. So from there I want to be able to tie the single step into cycle start so that when it's in single step mode, it feed holds, it goes into single step, and then the cycle start button or the play button in the interface will allow it to single block through. The reason for that is because on the majority of industrial machines there are a feed hold and cycle start button, but then there is a secondary button somewhere on the control panel, or it's even a flip switch on some brands of machines. You flip a switch and it goes into single block mode. In LinuxCNC, it seems that there is play, there's pause, there's single step, and then when you press pause again, it resumes. Not quite keen on that just because of the amount of years that I've been in the field working on machines that don't operate in that fashion. So what I'm going to do, and you'll see I'm kind of working on it right now. I have some logic in here tying to 2 buttons up at the top here. The 2 buttons are my PlayStation controller, and the button underneath it is the physical cycle start button that's going to be installed on the operator panel. Then down below that, this circuit, you'll see I have a set and a reset coil going to output 13. Here I've got an input that's going to be tied to my feed hold switch. I still have to work the logic out on this, but this will be part of an upcoming video. But right here I have my momentary circuit using the set and reset coils as seen in the modify menu, the S and the R. So the S and the R coils, what these do is they talk to each other. And what will happen is when the set coil goes true, it will latch an output, or it'll latch whatever it's set to in LinuxCNC, and it'll hold that state until a reset coil of the exact same designation is triggered. In this case, I'm just latching internal bit B11. But you can use it for latching any kind of outputs going to LinuxCNC. The bad thing about these is that you don't see them in the latched or unlatched state. So, from what I understand in the LinuxCNC documentation under Classicladder, it even specifies try not to use these as often as you would feel compelled to do. write latching circuits to kind of circumvent these, but they're there, they're easy to use, and quite frankly, if it's easy, it's for me. So getting into it, what I'm going to do is I'm going to tie in my trusty PlayStation controller to utilize one of the buttons to control input number 20. Now input number 20 is going to pass through this circuit and the circuit right below it. There are a normal open and normal closed or make and break coil tied to each of the rungs. The B11 set and reset tied to a B11 break input down at the bottom, and that passes along to output number 20. So to show you that, I'm going to go into our best friend, the HAL configuration. We'll go to our watch list. We'll go to our pins, classic ladder, and we will take a look at our inputs, 20, and we'll look at our output, 20. And the B's you really can't see unless you go to the VARs list, because the VARs, or the B and the VARs, are internal, so you're not going to see that unless you look here. Now, you'll notice that I'm using input 20 and output 20, and that on my left-hand side, I've got a whole slew of, I've actually got 50 inputs, 50 outputs, 50 S32s, and 50 floats. The reason for that is you can define however many inputs, outputs of every type you need in your ladder program by changing your HAL file. So not to get too sidetracked, if I go into my rant mill folder here, and I go under rant mill HAL, under the classic ladder _RT, this numfizz inputs I have set to 50, and everything across the board I have set to 50. The standards are like 15 and 10 or something like that. You can define up, I went up to 999, I believe. No, maybe not. I think it was less. I was testing around with it. I got up to 120. I tried 999 of each, and it didn't really like that. But I got up to 120 of each, and it started to throw the number order into a tizzy. Going back to here, it would show like from 10 it would go to 100 and 100, 101, 102. And then it would go to 11 and 111, and it was weird. But I was able to get at least 120 I/O out of my classic ladder list here. So you can really define a crazy number of inputs and outputs for your ladder project. I don't recommend it, but it's there if you need it. But yeah, don't try 999. It did not like that. So anyway, I've got my in 20, my out 20, and then again, if I go to VARs, eventually it'll pop back up. There. It's here somewhere. There we go. Our bit status right here. So looking at this, I want to assign input 20 to my button. So I'll go to my show, under test HAL command, I'll say net, and we'll call this test toggle. And we'll tie that to classic ladder .0.in-20. And we'll also tie that to input .0.button -X. So now when I press the square button on my PlayStation controller, you'll see that a couple of little crazy things happen. If I go to my watch list, and if I bring up my bit status here, and you look at B11, you'll see that when I hold my finger down on the button, it does some crazy, crazy stuff. The reason for that is because as I hold my finger on the button, the input stays true until I take my finger off. So now it's a crapshoot of whether the output is turned on, the output's turned off. It's not a very robust way of doing. So to alleviate that, what we could do is we can change the standard input of I-20 to, in this case, a rising edge input. Now, rising edge input thinks that the switch is normally open, and it waits for a close signal, and once it hits that close signal, it peaks and it drops. So it's a very short burst of momentary I/O, basically. If we go to our configuration, I had to reboot real quick, so I will call those pins back up. And we will go to our input 20, our output 20. And now when I press the button, regardless of how long I hold my finger down on it, it only momentarily pulses the button long enough to flip the circuit from the set to the reset. Now, if this were a normally closed switch, and I could show you that because the PlayStation controller actually has a NOT input on each of the buttons. So the button X and the button X NOT are just opposite to one another. So think of the button X NOT as a normally closed switch and button X as normally open. And when I press and hold button X, it goes true, and when I release it goes false, but button X NOT goes from false to true. You see, so now it's false, true. So to show you a falling edge, think of a falling edge as you have a normally closed switch and you want to break the signal momentarily and basically do the exact same thing that we're doing here, but with a normally closed switch instead of a normally open switch. So what I'll do is I'll change my classic ladder into 21. I'll change my button X to button X NOT. And I'll change my test toggle to test toggle fall. So now if I go into my editor, I'll create falling edge inputs. I'll select each one of these and I'll make them I-21. Hit OK. And now when we go to the watch list, we'll see that we have button X NOT and we have our falling edge inputs all tied to the test toggle fall. And now when I press the button, it does the exact same thing. It performs the same basic toggling, but with a normally closed switch instead of a normally open switch. So it's just a momentary on and off, or off and on, depending on the switch, that you can use in your toggle circuit to just momentarily trigger and change between the set and the reset coils. So now if you remember in previous videos, I've said that PLC and Classic Ladder, they don't really care whether your switch is normally open, normally closed. They're just looking for either a 0 or a 1. They're looking for digital input. The rising edge and falling edge inputs generally work in the same way. So what I mean by that is right now I've got my I-21, which is set to a falling edge input with a normally closed switch. So using that, again, when I press the button, it instantly triggers the change. But now if I were to assign that same exact normally closed switch as a rising edge input, you'll see a little bit of you'll see a little bit of a strange thing happen. So right now I've got my finger on the button, but then when I release it is when the change actually occurs. So you see right there, if you look at the watch list, we go false, then true. False, then true. And the same would happen if I did the opposite, and I went in and I made these I-20 to go back to my normally open switch, and I changed these to our falling edge input. Hold the button, input button X goes true, but the circuit doesn't change until I release. So it has to go high, low, and then internally it thinks it's high again. High, low, high. Or low, high, low, depending on how you're looking at it. So that about wraps up this video for your rising edge, falling edge, and set and reset outputs. I hope that this was clear as a muddy lake for you guys. Essentially all you're doing is just triggering the same button to toggle your internal set and reset bits, and then carry that down to an input with the same label to trigger the output that you so desire. And I could even tie that to something here. I can tie it to, let's say motion. Now we'll say motion digital in -00. I'll say net input something. Something, learn how to spell. Classicladder .0.out-20, and we'll say motion .digital-in -00. So if I go to my watch list, I now have motion digital in, and I toggle, and it goes on, and I toggle, and it goes off. So again, just by changing the state of this output in the middle here by means of this toggle circuit, we can get one button to do basically the job of two buttons on and off. And as a little side note, the next thing that I want to get into is going to be variable assignments. We'll save that for another video. I'm trying to keep these 20 minutes or so. So for the next video, you'll notice that up in here I have a comparison variable, which is located right here. But the comparison variable is just set up for a comment that just says momentary. You can do the same thing with the variable output assignment, and we can just say internal relay or something like that. You can leave little comments inside of these. They're not necessarily strictly for variable assignments and comparison. You can use them for some input commentary and output commentary. Also, the last thing I want to cover, if I go to my symbols, you will get a spot for all of your I/O where you can define names for everything. If you go a little overzealous, the list will eventually run out. So be careful with that, because right now I can't name my Q20 inside the symbol name. But just to show you, I can go down to I20, click on the symbol name, and say button-X. You'll notice that it changes the overhead input name to button-X. If I go to B11, under B11, I can give that a name of set relay, or just relay, relay-1. So it is unfortunate that I can't name output 20, because output 20 would be something that we would like to give a name to as well. But even these guys up here, I can give these names because they do show up on the list. So that being said, only use as much I/O as you're going to need, because for housekeeping purposes, it is nice to be able to put names to the faces, so to speak. And then if you click on the little check mark for display symbols, you'll notice that the inputs go back to their original values. They go back to I20, B11, and if I click on display symbols again, it displays the symbol names. So that about wraps it up for this video. Again, thank you so much for all of the kind words and all of the love that the videos have been getting. You're really inspiring me to put out at least a video every couple of days. I don't know how long that train's going to roll. I have to kind of pick up the information right before I pass it along, or else I will, or else I'll forget. So again, if you haven't already, please like and subscribe. And thank you for watching. We will see you soon.